Over the past 120 years, the development of aircraft has advanced significantly, with many different design approaches and concepts being experimented with. But today, we'll be taking a look at some of the most bizarre flying machines ever designed. Join me as we take a look at 15 of the most unusual flying machines. Number 15. Lockheed Martin P-791. Designed by Lockheed Martin's Skunk Works division for the U.S. Air Force, the P-791 is a hybrid airship that began testing in 2006. Built with a tri-hull shape and featuring cushions on the base for landing, the intent is for it to be able to carry heavy loads, partly by its buoyancy like an airship, and partly by aerodynamic lift like a plane. Unfortunately for the company, it lost out in the race to be the design chosen by the Air Force, as they went with the one by Northrop Grumman, but Lockheed Martin decided instead to convert the P-791 for civilian use and has so far received orders for 12 of them. With the ability to carry 2 crew members along with 20 tons of cargo or 20 passengers, there are plans to develop larger versions, and with the overall aim of companies reducing carbon emissions, craft like these could be far more common in the future for cargo transport. The production version is now known as the LMZ-1M, and although it's passed all FAA certifications, the first commercial flights are expected to begin within the next year or so. Number 14. Volante Vision. With the technological advances of the past decade, companies are now able to explore plane design like never before, and perhaps one of the most radical comes not from an established aircraft manufacturer, but instead from a company that builds cars. The Volante Vision is Aston Martin's concept for the future of personal travel and was created in collaboration with Cranfield Aerospace Solutions and Rolls-Royce. With a cabin designed to accommodate 3 people, the autonomous vehicle, which is hybrid electric, is seen as a solution for urban and intercity travel. Fitted with 4 tilting front propellers and 2 vertical stacked propellers at the rear, it'll be capable of vertical takeoff and will have fixed wings and twin rudders for forward flight. With an emphasis on low carbon emissions, the Volante Vision will in theory have a cruising speed in flight of 250 miles per hour, with a range of up to 500 miles. Expected to cost around $9 million, Aston Martin is well underway in the development of this new craft that's unlike anything that's ever been built before it, and it's expected to be available to customers by the mid-2020s. Number 13. Rutan Model 202 Boomerang. We're so used to seeing aircraft that are symmetrical in design that it's easy to think it's a basic principle of how they need to be. But not everyone is actually built that way, and there are some surprising benefits that come as a result. Based on the Beechcraft Baron 58, the Rutan Model 202 Boomerang is one of the most recent examples of this, and was the result of intensive design and development by famed American aerospace engineer Burt Rutan. He wanted to develop a plane that was multi-engined, but would also still be easy to control in the event of a single engine failure, something that would normally cause control difficulties otherwise. By using an asymmetrical design, the Boomerang was able to fly faster and for longer than the Baron 58 that it was based on, even with smaller engines. To make up for the unusual shape, each of the 2 engines was rated slightly differently, so that the one on the right produces 10 horsepower more than the one on the left. And as planned, it still operates perfectly fine, even if one stops working. Only one Boomerang was ever built though, and despite attempts to make it part of an air taxi service, it's now only ever seen on rare occurrences at air shows around the world. Number 12. Evolo Multicopter. Drone technology has progressed a huge amount in the past decade, to the point where it's now more affordable than ever to buy a high-tech, extremely capable one for home use. But as battery designs become even more efficient, developers are now turning their sights on supersizing what's already available. This will eventually mean the ability to carry heavier loads that can be done right now, and could bring about a new revolution in personal transport. One of the frontrunners is the Evolo Multicopter, which is a 16-propeller design that's already been tested and shown to be feasible. The company plans to make single and dual-seater versions, as well as an unmanned model, and they can all be controlled remotely or by a passenger. The enclosed cabin beneath the props lowers the center of gravity and provides a reliably stable ride experience, and the company boasts that the complexity of the onboard computers means that anyone can fly one. Right now, the multicopter is only able to fly for around 20 minutes before the batteries need to be recharged, but in the coming years, it's hoped that this will be extended to several hours, meaning they'll be ideal for flying short distances on battery power alone. Number 11. NASA Helios. NASA is at the forefront of vehicle design, having been the only organization to land people on the moon. But now a lot of what they do involves the development of Earth-based aerial vehicles that can then inform them about design principles that could work elsewhere in the solar system. One of the most unusual they've ever created was the Helios, which was essentially a solar-powered single wing that could in theory stay flying in the air indefinitely. Hoped to lead to the creation of high-altitude aircraft that could act as atmospheric satellites and as communication platforms, the ultra-lightweight flying wing aircraft was 247 feet long, giving it a much wider wingspan than that of a Boeing 747. It was mainly made from carbon fiber, graphite epoxy, and Kevlar, and on its surface was a transparent plastic skin. Solar panels, which were made up of more than 62,000 cells, were placed across the top to provide power for the propellers and onboard technology, and there were 72 trail-edge elevators to provide pitch control. The wing was designed to flex depending on its surrounding conditions, but this would ultimately prove to be its undoing. During a test flight in 2001, less than a year after it first successfully took to the sky, it warped too much in turbulence and disintegrated. NASA never rebuilt the Helios, but the data that was collected during tests was used to help develop new satellites and spacecraft that now rely more on solar power than ever before. Number 10. Terrafugia, flying car. We've been able to have personal transport in the form of cars for many decades, but the ability to fly from place to place has required having your own dedicated aircraft, and usually an airport that you can take off and land at. It's long been a dream for many people to be able to combine the two, to have a flying car, and technology has now reached a point where this is becoming a reality. Terrafugia is a company that was formerly based in Massachusetts, but has now been relocated to China and is leading the way in this sector, having been developing a roadable airplane since 2006. The current model, known as the Transition, has now been granted an airworthiness certificate and is soon expected to be certified as roadworthy, which will mean customers will be able to start using one. Made from carbon fiber, the Transition has a range of 489 miles when in flight and can travel at speeds of up to 107 miles per hour. On the ground, it can reach 70 miles per hour and can neatly fold up to a dimension suitable for use on road. When it's time to fly, a simple press of a button will see the wings unfurl and the propeller emerge. The company hopes to be able to sell them for less than $500,000 each. Of course, you still need a pilot's license to use one in the sky, but there are hopes that autonomous versions will also be available in the coming years, which could potentially be operated by anyone. Number 9. Airboard 2.0. Developed by Dragon Air, the Airboard 2.0 was initially designed for a flight competition, but could well become available to customers in the coming years. Described as a one-person electric vehicle takeoff and landing hover bike, it's made of carbon fiber and achieves lift with its 4 pair of coaxial motors that spin a series of 40-inch propellers. The pilot stands on top and has 2 ski pole-like controls, and despite being a new type of control system, it's said to be extremely easy to learn. The 2.0 is still seen as a prototype, but can easily lift up to 20 feet in the air, and the next version is expected to be even more powerful. Unlike other flying machines, the Airboard 2.0 is initially being seen as a potential recreational vehicle rather than an alternative form of transport, but the creators have suggested a range of other uses, such as in the agricultural industry or for search and rescue, where it's useful for someone to be able to move quickly around tricky terrain and have a higher vantage point of their surroundings. Number 8. The K-MAX. The fact that helicopters even work is a remarkable feat of design and engineering, but the K-MAX takes things a step further and is far from your typical type. You'll notice at first that this doesn't have a tail rotor at all, and the stability that this brings to normal choppers is instead provided by the fact that it's classified as a syncropter, which means it has 2 main rotor blades that are counter-rotating and set at a slight angle against one another. Designed specifically for lifting heavy cargo, which can weigh more than the helicopter itself, the K-MAX has a wedge shape to give the pilot a much better view of what's below on either side of the aircraft from the cockpit. Originally built between 1991 and 2003, production has restarted again due to increased interest from customers around the world, as aircraft like this can be much better suited to tasks like firefighting than other options. The company is now also working on the development of an unmanned variant of the K-MAX, which will allow operators to fly one into dangerous areas like disaster zones or wildfires without risking the pilots. Number 7. Otto Ornithopter. Heavier-than-air powered flight was first proved to be possible by the Wright brothers in 1903, using a design based on the principle of generating lift under a fixed wing, which is how the majority of modern aircraft work. People had, however, been trying to develop flying machines for far longer, and one area of research was looking at how to replicate the natural flyers in nature, such as birds, bats, and insects. A machine like this is called an ornithopter, and even Leonardo da Vinci proposed his own ideas for something like one in the 15th century. The first person to build a viable one, though, was called Otto Lilienthal, and he piloted his design, which was human-powered in 1894. In the following decades, several other ornithopter designs were built, which again used human power and essentially replicated the flapping wings of a bird. Featuring huge wingspans, they operate in a similar way to a glider, whereby they're released at altitude and are able to maintain the height on their own. Even to this day, hobbyists continue to build ornithopters with unmanned and manned versions, but the most groundbreaking of all was called Snowbird, and it became the first one able to fly straight and level. Designed at the University of Toronto Institute for Aerospace Study, it had a wingspan of 105 feet, and after being towed by car to build up speed, was able to fly 476 feet above the runway. Number 6. Blohm + Voss BV-141. The realization that aircraft don't have to be symmetrical wasn't something that was discovered in recent times, and the German Air Ministry actually had the option to put a version in development in 1937, which would surely have become the most unusual aircraft in the Second World War if it had done. Known as the Blohm + Voss BV-141, it was designed to be a tactical reconnaissance aircraft to fulfill the requirement of being powered by just one engine, but offering unparalleled visibility. The pilot, observer, and gunner would sit in the shortened plexiglass fuselage on the starboard side, and the port side housed the BMW 132 engine and tail unit. This gave the tail gunner a great field of view and made it ideal for reconnaissance, with the problems you'd think it could create being easily overcome. The uneven weight, for example, would appear to make it subject to roll, but the lift generated by the wings easily prevented that. There wasn't an issue with uneven drag being generated either, because of a little understood phenomenon called the P-factor at low speeds and the use of trimming at normal airspeeds. Ultimately, though, it was the unavailability of the engine it used that meant that the Blohm + Voss BV-141 never went into full production, and officials instead chose to go with the twin-engined Focke-Wulf FW-189. Number 5. Flycart 2. This incredible-looking machine is the Flycart, and it's the prototype version of what the creators hope will become a production vehicle in the near future. The follow-up model is known as the Flycart 2, and the rendered images show just how close to reality it is. The machine has been developed by a company that specializes in shrouded propeller technology, which can be applied to a range of different vehicles. The most exciting is the Flycart, though, which is intended for recreational use. Officially classified as an all-electric vertical takeoff and landing aircraft, it has a single seat in an open cockpit that's surrounded by 10 shrouded rotor fans. With components made from carbon fiber, it is incredibly light, and this means the majority of the power generated by the fans can be translated into flight performance. With a width of about 6.5 feet and a length measuring 6.2 feet, it's able to reach a top speed of 63 miles per hour and can remain airborne for more than half an hour on a single charge. It also features an autopilot and redundant battery as a safety feature to ensure it returns to the ground safely and will hold the pilot firmly in place with a 4-point safety harness. If all goes to plan, the batteries of the Flycart will be improved and there could well be a racing league within the next few years. Number 4. Caproni CA-60 Novaplano. Most planes you see have one set of main wings, and occasionally you'll see one with two. But in the early stages of aircraft design, it was believed that the more you had, the more lift that would be generated. This led to the creation of possibly the strangest aircraft to ever take to the skies, the Caproni CA-60 Novaplano. It was the brainchild of Gianni Caproni, an Italian aviation enthusiast who dreamt of building a transatlantic aircraft. With space on board for 100 passengers, his flying boat pushed out all the stops and had 9 wings arranged in 3 sets. Each of the sets had a wingspan of 98 feet, and the fuselage was 77 feet long. It was powered by 8 Liberty V-12 engines, which were the most powerful produced during the First World War, and the resulting structure was so complex that numerous connecting beams were needed to increase its rigidity. To much celebration, the Novaplano emerged from its hangar in January of 1921 and conducted its first test flight on March the 2nd. It was during this second flight, however, that disaster struck and slammed into the water before breaking up. The damage was too extensive to repair and the design seen as too radical to warrant a complete rebuild, meaning the Novaplano has been consigned to history without knowing for certain whether it would have been able to fly across the Atlantic like it had been designed to do. Number 3. Hafner Rotobuggy. During the Second World War, a number of different vehicles were created with the hope they would provide functionality that would be useful to the cause. And in 1941, the British Airborne Forces Experimental Establishment began looking at ways to airdrop off-road vehicles, and they created the Hafner Rotobuggy. They had found that a U.S. Army truck could be dropped from a height of 7 feet without suffering any damage, so proceeded to fit one with an almost 41-foot diameter rotor blade. The result was the world's first flying car, which needed to be towed to takeoff speed before being capable of maintaining flight on its own. After tweaks to the design, its most successful test saw it fly at an altitude of 400 feet for 10 minutes at a speed of 65 miles per hour. But unfortunately for those behind the project, it was at the same time as gliders could carry vehicles were also proving to be successful, so the Rotobuggy was no longer needed. Only one was ever built, and it was scrapped for its metal later on in the war. Number 2. NASA A-1 Pivot Wing. Aircraft generate lift by their forward momentum and the way that the air passes above and beneath the wings, and in most designs the wings remain fixed in one position as to be as stable as possible. There had long been the suggestion, though, that wings would be more efficient at an angle when in flight, and NASA decided to test this between 1979 and 1982 with the A-1 Pivot Wing. The subsonic jet-powered research aircraft looked fairly normal on the ground, but its wings had been designed so they could move between 0 and 60 degrees while in flight. Powered by 2 turbojet engines, the A-1 had a limited top speed of 170 miles per hour and went on to perform 79 test flights. Over the tests, the angle of the wings were slowly increased to see how they affected performance, and the results were mixed. It was found that at angles over 45 degrees, there were pitch rolling effects that caused the handling to be virtually unresponsive and far from safe for any mass-produced aircraft. The people behind the project pointed to a number of problems with the test, though, and maintain to this day that the idea of the oblique wing is still viable. They insist that at higher speeds, the control difficulties would resolve themselves, and that if the plane was sturdier, not made of fiberglass like the A-1, this would also have significantly improved things. For now, there are no plans to revisit the idea, but who knows what's possible in the future. Number 1. McDonnell Douglas X-15. You'd think that developers are constantly trying to create faster aircraft than ever before, but amazingly, the airspeed record was broken in October of 1967, and since then, nothing's got close. That's because the craft that managed it was the McDonnell Douglas X-15, and it's the most radical design ever built. Classed as a hypersonic rocket-powered aircraft, the X-15 was 50 feet long and had a wingspan of 22 feet. It was powered by a single reaction motor's liquid-fueled rocket engine and had a range of about 280 miles and a service ceiling of 67 miles, and an astonishing top speed of 4,520 miles per hour. The reason it was able to travel so fast was the combination of its engine and the fact that it flew so close to the edge of space where there's so little air resistance, and each of the 8 pilots who took it to its limit were classified as astronauts in the process. 3 of the aircraft, which look more like missiles, were built, and rather than taking off from a runway, they were designed to be dropped from the wing of a B-52 mothership. Of course, there's no actual practicality to an aircraft like this beyond being used to test various engine setups and conditions, so it's no surprise that their operational lifespans were short-lived, and it's unlikely that any manned aircraft will ever be built that's able to go faster than them.
Watch our Vehicles playlist for more top 15 videos about amazing vehicles. Sit back, relax, and binge watch all of our best vehicle videos.